Hello. Today I'd like you to work on writing a linear equation to model the growth pattern that you see in a figure in a series of shapes. So this is page 5 of your linear equations packet. This is page 5 that you'll be working out of today. But before I have you start on page 5, let's just go back and review a little bit about what these linear equations look like for modeling these situations where there's a constant rate of change. Let's look actually at page 2 for a second. If you look at page 2 of your packet, goes back to the cup and the marble problem. Remember when we were looking at this one, the mass of the cup was 300 grams. Every marble was 5 grams. So every time you'd add one more marble to the cup, the total mass would go up by 5. And so what we ended up seeing was with 0 marbles, it was just 300. With 1 marble, it was 300 plus 5. 2 marbles was 300 plus 5 times 2. 3 marbles was 300 plus 5 times 3, and so on. So we started seeing this pattern so that when we wrote the equation y, the total mass, was equal to the 300 that we started with, the beginning point, also known as the y-intercept, plus the mass of all the marbles that we added. And to calculate the mass of all the marbles that were added, it was 5 grams per marble times the number of marbles. So all of these linear equations end up taking the same form. Some amount y is equal to a beginning amount plus, or maybe minus, a rate of change multiplied by the x-coordinate. So they all look the same. If we now turn to page 5, if we look at some other examples, we did this right side earlier, but in this case, we were looking at Zaire. She has $80 and she starts saving $15 per month. So when we wrote the equation, the total amount of money that she has is the money that she starts with plus what she saves per month multiplied by the number of months. For number 2, Gunnar, he sees the zombie. It's 57 feet away and he starts running away from it at 14 feet per second. So D, his total distance from the zombie, is 57 feet that he begins with, plus the distance that he runs, which is 14 feet per second, multiplied by the number of seconds. So with that little background, let's come over here and let's start working on this left-hand side. So I see this figure of patterns. Step 0 is left blank. We'll have to fill that in. But I can see how many squares there are in step 1, step 2, step 3, and step 4 is left blank. That's for us to draw again. So we need to make sense of what's going on here. So we're supposed to draw step 0 and step 4, then complete the table, which ends up having us write a little expression for the number of squares in each step. And then we have to use the equation down here. So the first thing I'm going to have you do is, why don't you try to draw step 0, draw step 4, fill in the numbers, and if you count how many are in each of these steps, it'll help you to see the pattern for what step 0 and step 4 need to be. So I'm going to ask you to pause the video, count steps 1, 2, and 3, draw steps 0 and 4, and add it to the table. So please pause the video and then start it back up again when you're finished that part. All right, let's see what you've got here. So in step 1, I've got 1, 2, 3, 4, 5, 6, 7. In step 2, I've got these 5 across the middle, 1, 2, 3, 4, 5, and then 6, 7, 8, 9. And for step 3, the 5 across the middle, 6, 7, 8, 9, 10, 11. So already I can see the pattern. It's not a complicated one. Every time you add another step, you're adding 2 more. And I can see why. There's this horizontal piece, and then which stays the same in every case, but we keep building on the vertical piece. So every time we go up a step, 1 square gets added to the top and 1 gets added to the bottom. Another gets added to the top, another gets added to the bottom. So there's the 2 that we're adding. So what should step 0 look like? Step 0 should just be the 5 in the horizontal piece. What should step 4 look like? Well, let's draw the 5 in the horizontal piece. There's your 5. Step 3 had 3 on the top and 3 on the bottom. Step 4 is going to have 4 on the top and 4 on the bottom. 1, 2, 3, 4. 1, 2, 3, 4. Which is going to get us up to 5 plus 4 plus 4 is 13 right there. 13. So now when it comes time to write the equation, that's what I want you to do next. Let's write an expression right there for what that needs to be. So again, think about what's the beginning point, think about what the rate of change is, and then we're going to be adding to the beginning point or taking away from the beginning point. So why don't you pause the video, try to write that expression, and let's see what you got. All right, let's see if we can do this thing. All right, let's switch to this color here. So x is the step number. X is step number, y is going to be the total number of squares in that step. So let's see what we got. No matter what the step number is, we always start with the 5 in that horizontal piece. So we're going to start with 5. And as the step numbers increase, we're going to add to those 5, not take away from those 5. So it's going to be 5 plus something. And how many do we add? Well, we add 2 squares for every step multiplied by the number of steps. Does that actually work? Does that work? If we just try step 2, for example. 2, that's a step number. That's an x value. If x is 2, 2 times 2 is 4, and 5 plus 4 is 9. It works. How about step 4? If x is 4, 2 times 4 is 8, 5 plus 8 is 13. This expression works. So now what we can do is we've got this equation. I'll even write it over here. Let's go like this. If I've got this equation, let's say y, the total number of squares, is equal to the 5 that we start with plus 2 squares for every step multiplied by the number of steps. What will be the total number of squares for step 20, and what step are we in if the total number of squares is 73? So here's one more pause. Pause this thing, try to do those 2 calculations using the equation that we've come up with to model the growth of this pattern, and let's see if we can use that. So please, pause it, calculate those 2, begin. All right, so let's see what you've got. Here's where the equation becomes very useful to us. We could just keep extending this data table. We could go to step 5 should be 15, step 6 should be 17, step 7 should be 19. We could just keep going until we get to the 20th row, but that's annoying. That would take too long. So let's just use the equation, and then in 2 quick calculations we'll have our answer. So let's see. There we go. Okay. So let's use this equation. Y, the total number of squares, is equal to the 5 that we start with, plus 2 per step times the x steps. So let's write this. 5 plus 2 times x is 20. And what does that equal to? 5 plus 2 times 20 is 40, and 5 plus 40 is 45. So for step 20, there should be 45 squares. We don't want to have to draw it. That would be annoying. We don't want to have to make a data table that goes to row 20. That would be annoying. Let's just use the equation to make our life easier. Algebra is so wonderful. Algebra is our friend. Let's try one more. What if the number of squares is 73? What step are we in? Well, 73 is more than 45, so I know we're in more than step 20, but it's going to be a lot more, but I don't know what it is exactly. Let's not extend the data table indefinitely. Let's just use the equation. So I know y is equal to the number of squares, the total number of squares is equal to 5 that we start with, plus 2 for each step times x steps. And I know it says 73 is my total number of squares, which is a y value. So I'm going to put 73 in for y this time. 73 is equal to the 5 that we start with, plus 2 for each step, times the number of steps. Now let's just solve for x. What step number gets us to a 73? Let's take away those 5 that we start with. So that means we've got 68 is equal to 2 times the step number. And if I then just divide by 2 and divide by 2, I know I'm going to have 34 is equal to my x value. So I know this is going to be true at step 34. I'm going to have 73 squares in this pattern. So hopefully that helps looking at a growth pattern and being able to write a linear equation to match that constant rate of growth. So hopefully you're doing well. And I hope that makes sense.